What's up, guys? Yeah, so previous video I already discussed the average function of the divisor and the sum of the divisor function. So this video I want to talk about the famous results of the average function of the Euler phi function. So our goal, let me just using so our goal is to find is try to find the Euler function, the average order of this Euler function. And I think previously I already discussed the Euler function phi of n to be the I should say the number of the so the integer which is positive integer which is coprime to n, right? So for example, 5 of 10 is 4 because 1 3 7 9 here. Okay, and this function has many arithmetic and the number theory, also group theory. You can prove that the 5n is defined to be the order of the another definition is the order of the multiplicative group with the n and the multiplicative group. Okay, so or you can define it into the dimension of this Kite-Holomy field with the rational coefficient, where this data n is exponential to pi I divided by n. Okay, so this is also another definition. Yeah, so but in the analytic number theory, which is very interesting, that we want to bound these terms. Okay, so our goal is to prove these guys 3 divided by pi squared x squared plus O of x log x. Okay, so this is our goal. Hope you guys subscribe to my channel. Okay, so in order to do this, right? So in order to do this, so the idea is that we start from the known arithmetic function and go to the unknown arithmetic function. Okay, so one is very related to this 5n is the Mobius function. I think previously I already proved this by using the Dirichlet theorem. Dirichlet convolution. So you have this. So the goal is to just find. So if one can find the bounds for this mu of d, then one can just using this formula and basically the same technique that I just mentioned previous time. So every time you have sum of the n less or equal to x, d less or n, you can change into summation d less or equal to x is mu of d. So I use mu, and q, where q less equal to x divided by d. Okay, so this is just a definition that you define q to be n divided by d. Okay, so these summations will break up into 2 summations. Okay, so you got a summation d less or equal to x mu d, and do the sum of q, right? So this is just half of x divided by d squared plus the linear term, which is x divided by d. Okay, so now you can pull out this x squared and do some computation, right? So you get a half of x squared summation mu d squared d less equal to x plus this O of x over d less equal to x. Okay, so these terms can be easily controlled by using a log, right? So this is just O of x log x by this sum over 1 over d. So the rest is just find this mu of d divided by d squared. Okay, so this is very simple, right? Because we have the following. We know the zeta function 2 is 1 over n squared. Okay, then you can use your lovely Taylor series for analysis. However, at least I know 4 methods to prove this pi squared divided by 6. So you can check out my previous video. So in it, so the quicker way is that you do sin x divided by x, and you know that this is 1 over x squared divided by 3 factorial, x4 divided by 5 factorial, and you need to separate it into the roots of x squared, right? So you can prove it's basically this, right? Because x equals to the multiple of pi will be 0, so you can do. So now you can equal these x squared terms, so you get summation of 1 over pi squared n squared, and from 1 to infinity will be 1 over 6. So you get summation of 1 over n squared, and from 1 to infinity will pi squared divided by 6. So you get this one. Okay. And these terms, okay, so the question is that so the rest is just so we got this data too, right? So the idea is that we need to find these terms. Okay, so here is the very very amazing idea that very amazing that idea is that if you look at this data too, right? This data too has this. And also, it has also a very beautiful idea. It's called Euler products, right? So theta S is basically 1 over prime the product of prime P, 1 over 1 minus P to the minus S, right? So it's this pi to P minus 2 prime P, or this P, this. Okay, so you get this. Okay, so if you do this 1 over 2, 1 over theta 2, you get the product of P 1 over P, 1 minus 1 over P squared. Okay, and if you do this, then you also get the every terms, right? You also get every term like 1 over n squared, but with some factors. And you see basically how many factors that you have, right? If you have the even vectors, then even the factors is positive and our factor is negative, right? So this is indeed mu of n, right? But if there's a square free, then there's no such kind of terms. Okay, so we should basically just say that, just saying this. Okay, so this is very amazing, so amazing. Okay, so once you have this, then proving the rest is trivial, right? Because so our goal is to bound these terms. Okay, so what should we do, right? This term is basically bounded by this 6 pi squared, right? And with the arrow term come from this 1 over d squared. So once you got this idea, then it's very easy to prove. Okay, so let me just write down. So you got this, and you can write as a 6 pi squared minus mu of d squared d greater than x, which is 6 pi squared plus this O 1 over n squared, unless less greater or equal to x, right? So this is a 6 pi squared plus this 1 over x, O of 1 over x. Then once you get this, right, you can plug in back into these terms. So you get half of x squared, 6 pi squared plus O 1 over x plus O of x log x. Okay, you get 3 squared divided by pi squared O of x log x. Okay, so this is the common results of this. Okay, so let me just remind this data to a little bit. So there's a problem that people like to ask. I mean, for some strange interview that. So the problem is that if you pick two numbers to positive integers, A, B. So what is the probability that they are coprime? So what is the problem? They are coprime. Very stupid question. Okay. So basically, what you pick two numbers and then you ask what is probability they are coprime, right? So the probability is very easy, right? So if they are coprime, that means that two cannot be both, right? So you can so what is the probability that the first one will be the multiple of 2 is a half, right? When the second is half. So this 1 minus 1 over 4 means that at least one of them is not divisible by 2, and at least one of them is not divisible by 3, and at least one of them is not divisible by 5, and at least one of them is not divisible by 7, right? So you can check that this is just sum over the product of P 1 over 1 minus P square. Sorry, you can this is basically this. Okay, so this is a P squared minus 1. Okay, so P is P, and yeah, basically like this is probability, right? It's like this, right? And then if you just look at it, if you look at it, you can see that this is just 1 over theta 2. Right? The reason is that this theta 2 is defined to be 1 over P, 1 over negative 1 over P squared. Okay, so this is just p squared minus 1. Right, so if you see this, it's just a flip of this. Okay, so the probability of any two integers, you pick up any two positive integers which are the coprime is basically 6 divided by pi squared. Okay, so very stupid question. I just got remind once I film this video. Okay, so hope you guys subscribe to my channel. See you guys next video.